Welcome to Mr. Benjamin's Math World. My nephew just asked me this question and I wanted to share the answer with you. The title says, to change or not to change. He asked me, why when moving the negative side, the negative 5 from the left to the right, why do not change the sign to positive? And this is the answer. When moving one term from one side to the other side, it goes with the opposite of the operation involved. It means, what's the operation involved here? Is it a subtraction? It is not. This is a multiplication. It's a multiplication because negative 5x means negative 5 times x. I said times, which is multiplication, and the opposite of multiplication is division. So when moving this term from this side to this one, it goes dividing without changing any sign that it has. So simply this will be x equals negative 5 multiplying goes dividing. If it goes dividing, it's always, we know this, in the denominator. That's why I always tell students, you bring down the term that is waiting for the other one to go. So since this is the one that is going to be moved, it's multiplying, goes dividing, it's negative 5. 25 divided by negative 5, x equals to negative 5. Let's prove that this is true. X is negative 5, so this will be negative 5, this one here, this negative 5. Because this is the result for the x. And this is the x, which is multiplication, right? Negative 5 times x, which is negative 5. Negative 5 times negative 5 equals, I'm just copying the same, 25 to see if it's true. Negative 5 times negative 5 equals to 25. The sign, negative times negative equals to positive, equals 25, 25. Is 25 equals to 25? Yes, so this is check, is correct. Same on this one. Here it says x divided by negative 5 equals to 4. The negative 5 is dividing. If it's dividing, it goes multiplying. It means that the operation will be a multiplication. You don't need to touch the sign. You keep it the same. So since I'm moving the negative 5 from the left to the right, it goes multiplying. This one will be left alone. So the variable x equals, copy the 4, which is waiting for the negative 5 to go. Bring down the 4, and then dividing on the left, multiplying on the right, times negative 5. X equals 4 times negative 5 is negative 20. Let's prove negative 20. I'm replacing negative 20 is the x over negative 5 equals 4, 4. Negative 20 divided by negative 5 equals to 4. Negative divided by negative is positive. 4 equals to 4, yes. So this is check. About this one, a very simple one. You may ask, what's the operation here? I mean here. Here it says negative 3, which is the same as 0 minus 3. The operation here is a subtraction. It is subtracting. It has a negative sign. And that's why you move the negative 3, which is negative, which is subtracting. It goes adding. It goes with a positive sign. So since I'm moving this one from the left to the right, I'll bring down the x, copy the equal sign, bring down the 5, which is waiting for the term to go. The negative 3 goes adding, plus 3, so x equals to 8. Let's see if it's true that x is equals to 8. Let me replace Bring down the negative 3 plus x. Who's x? The 8 equals to 5. Negative 3 plus 8. The rule says, again, when two numbers have different signs in addition and subtraction, you subtract the numbers and you copy the sign of the greatest. When subtracting these two, the result is 5. What's the sign of the greatest? The positive, because 8 is greater than 3, so it's a positive 5, equals to 5. Is 5 equals to 5? Yes. So this is check. And this is the answer of my nephew's question. If this was a useful video, just subscribe and keep receiving for the notifications. See you next time.